Oh, I just remembered actually that our pterodactyl, our flying dino character, is going to be animated as opposed to the cactus or cactus group. So this whole sprite thing here doesn't really make sense because the pterodactyl doesn't actually need just a sprite, it actually needs a sprite animation. So therefore I'm going to remove this sprite field, and actually what I'm going to do is simply make the draw method abstract. That way the concrete implementation of the draw method needs to be provided by the subclasses of obstacle, which will be the flying dino class and the cactus group class, and they would then decide, or each have a different implementation of the draw method. One uses a simple sprite and the other uses a sprite animation. So yeah, I think this is a more suitable approach. So yeah, let's go back to the obstacle manager and let's actually make it spawn obstacles. First of all, let's create a field here that will be of type list of obstacles. And this will just keep track of the obstacles that we have already spawned. Well, do we need this? I mean, I guess we could just use the entity manager for that. Yeah, I guess we could do that. Let's remove this. I got a better idea here. Let's take a look at our entity manager. There is an entities property that we could use. Yep. I'm going to go ahead and enhance the entity manager a little bit here. And what I'm going to do is I'm going to create a method that returns an IEnumerable of t, and just call it get entities of type, and then I can provide a type, and I will add a constraint here. Let me just, oops. Like this. So I just implemented a generic method that returns all entities of a specified type. So now I can do something like get entities of type, and then here I could pass T-Rex, for example. So that would give me all of the entities that are actually of type T-Rex. So in case you're not familiar with generic methods, what I'm basically doing here is I created a method that has a type parameter. Like I said, you can just here in the method call, you can here pass a type that has to be a type that derives from iGame entity. In other words, it needs to be an implementation of the iGame entity interface. For example, like I said, T-Rex, or it could be anything, as long as it implements the iGame entity interface. So this now is a type-safe way to get all instances of iGame entity of a specific type. So I can simply use this now in the entity manager to keep track of the obstacles that are currently in the game. I don't need a separate list for that. The off-type method is actually an extension method from the link namespace, and it basically just filters an enumeration by checking if the type matches. So yeah, that's great. Now let's go back to the obstacle manager, and I'm going to go ahead and create a property, and I call it can spawn, or can spawn obstacles, and it will return if the obstacle manager is enabled, and if the scoreboard score is greater than or equal to the min spawn distance. So now can spawn obstacles will return true if is enabled as true, and the score is greater than or equal to the minimum spawn distance that we defined. So the score has to be at least 20 for the obstacle manager to actually start spawning obstacles. So yeah, what else? Now, in the update method, yeah, I'm going to add a field here. I'm going to add a field that stores actually it's going to be of type double. Let's call it last spawn score, and it's going to store, it's going to keep track of the score value as it was the last time an obstacle was spawned. So here we should now check basically if the obstacle manager can spawn obstacles currently, and if a certain distance has been reached. But first of all, actually, let's create a new field here. And I'm going to, it's going to be of type double, and let's say current target distance, something like that. And it will store a random value between these two values here, and it will determine the distance between the previously spawned object and the obstacle, the previously spawned obstacle, and the next obstacle to spawn. So let's see. Say here, if can spawn obstacles and the current score minus the last spawn score is greater than or equal to current target distance. And let's actually put this in parentheses. Let's see if this makes sense. So if the current score minus the last spawn score, which will be the score value as it was when the last obstacle was spawned, is greater than or equal to this random value between 100 and 500, then we want to spawn a new obstacle, right? So I guess when it's 0, we haven't actually spawned anything yet. So we should ignore this. So basically, let's say here, or whoops. Like this. So these are the conditions for the obstacle manager to be able, or to when it should spawn a new obstacle. So if it can spawn an obstacle because it's enabled and the minimum score has been reached, and if the last spawn score has not been set yet, it will be 0. So that would be an indication that we haven't spawned anything yet. So yeah, we're good to go. We can spawn a new obstacle. If it's not 0, then obviously an obstacle has already been spawned. So we should check if the current score, which is basically equal to the distance that the T-Rex has traveled, minus the last spawn score, is greater than or equal to the current target distance, which is a random value. Then we should spawn the next obstacle. Yeah, I think that's right. Okay, so let's go ahead. Maybe format this a little better, like, whoops, this, so you can actually read it on the screen entirely. Well, first of all, we need to define this current target distance. I mean, currently it will always be 0. But that's fine, because here we haven't spawned anything yet. This condition will be met. So basically we can then here set the current target distance to this new random value. So let's go ahead and say random next double. It gives us a value between 0 and 1, so we need to multiply this. By the max distance plus the min distance. And then subtract the min distance, right? So this, like I said, next double will produce a value between 0 and 1. Let's say it is 1. The max distance is 500. The min distance is 100. So this is 600. In total, it will be multiplied by 600, which will give us 600. And then it will subtract the min distance of 100, so that would be 500. So yeah, that is correct. So if it was 0, then obviously this multiplication would return 0. Oh, actually, whoops. So again, let's say this is 1. 1 multiplied by 500 minus 100 would give us 400, and then we add the minimum value, which would give us 500, which is correct. And if it was 0, this multiplication here would return 0, and then we add the minimum, yeah, which would end up being 100. So yeah, this is correct. It's actually formatted like this. Right, so yeah. What else? Now we need to actually spawn the obstacle, but we can't do that because we don't have a concrete implementation of the obstacle class. We can't do this because it's abstract. I mean, let's create a to-do here and say create or add create instance of obstacle and add it to entity manager. Like that. So we'll do that later. For now, I just want to make sure that obstacles that have left the screen, that are basically have reached the left-hand side of the screen, will be destroyed and removed from the game, so that the memory doesn't get cluttered. So let's say for each obstacle in entity manager get entities of type obstacle. So we'll use this generic method that we just created to get all of the entities that are of type obstacle and iterate over them, and then we will check their position. If obstacle position is less than let's say 100. We will say entity manager remove entity obstacle. And I'm saying 100 instead of 0 because the origin of the sprite of the obstacle will probably be the upper left, and we have to also factor in the width of the sprite. So just to be sure, I'm going to go with 100, or maybe even I could even say 200, just to be sure. So it will not be despawned directly after leaving the screen, but sometime later, but that's fine. As long as we eventually get rid of it. So but I think that's really all our obstacle manager needs to do, except obviously creating an actual instance of the obstacles. Oh yeah, I forgot one thing. Here we need to say we need to update the last spawn score to the current score value. But I guess that's it. Oh, okay, but maybe one more thing. Since it's never really a good idea to directly compare doubles or floats, maybe we should actually set the initial value of the last spawn score to something like -1 to indicate that it hasn't been set yet. I mean, we could also use a nullable double or something like that, but this will do the job just as fine. So we initialize it with a negative value to indicate that we haven't spawned anything yet, and here then we can check if the last spawn score is less than or equal to 0 to check that condition. And that's great. Here actually what I'm gonna do is remove this. Actually, I'm gonna cut it and then here say spawn random obstacle. And obviously this method doesn't exist. So what I'm going to do is right click this, quick actions, generate method, and it automatically creates a stub for this method. And here we will later on actually implement the spawn behavior, the spawn logic. For now it's okay for this to throw an exception. And let's paste the to-do right here. Okay, so what else? We need to actually implement the obstacle. So let's go into the obstacle class and what I'm going to do here is go up here and say public, what was it called again? Cactus group. Let's say public class cactus group, and it will inherit from obstacle. Whoops. Like this. And now the compiler will complain that it doesn't properly implement the abstract class obstacle. What I can do is here I can hover over this, click here and say implement abstract class, and it will automatically stub out the implementations for the abstract members. And it's still complaining, and that is because we're not properly calling the constructor of the superclass, of the base class, but we'll take care of that now. So let's say public cactus group. And what does the constructor need, really? Obviously, it needs all of the stuff that the base constructor expects, which would be the T-Rex and the position. So let's go ahead and do that. And then simply pass them here, like this. So the constructor of the cactus group class will simply chain call the base constructor and pass the T-Rex and position that has been passed to this constructor. And yeah, but we need something, we need more than that, I guess. First of all, let's revisit our texture in photo filter here. And remember, we said that these cacti, they always spawn in groups, basically. The groups are defined as, let's say, small, medium, and large. So the small group will be just one cactus. The medium group will be 2 cacti. And the large group will be 3 cacti. But that only applies to the small ones, to only the small cacti. For the large cacti, it's actually the small group is also just 1. The medium group will also consist of 2 cacti, but the large group will actually be these 4 cacti, including this little one here. So basically, first of all, we need a flag, whether or not it is well, to indicate if it's a small cactus or a large one. And we need to be able to define the size of the group, small, medium, or large. So let's go ahead and do that. First of all, let's add a Boolean value to represent whether or not it's a tiny cactus or large one. We could also use an enum for that. That would be fine as well, I guess. But since it's really binary, we can go with the Boolean. That's fine. Public bool, say, is large. And it will only have a getter. It will be a read-only auto property because it doesn't make sense to change the size of the cacti once they have been created. And then we need an enum type. I'm going to go ahead and actually we could use nested enum here. Public enum, say group size. And the values will be small, medium, and large. And now we can use this enum type to specify the size of the cactus group. So let's go ahead, create a property of type group size, and name it size. And this can also be a read-only property. We don't actually need a private setter because, again, it doesn't make sense to change that. So let's actually enhance the constructor a little bit. And here we need to be able to initialize these two values as well, like this. Oh, oops. Obviously I meant the property. Like this. And remember that the draw method of the obstacle class is abstract, so we need to provide an implementation of it. So we need to override the draw method here, and that's what we're going to do. And for the cactus group, the implementation of draw will be really simple. We just need to draw a sprite, and we first need to construct this sprite according to the values that have been passed here. So yeah, so for the if is large, if someone passes false for is large, obviously we need to spawn one of those tiny cactus groups, and otherwise we need to spawn one of those here. So let's see. Let's actually create a private method that generates the sprite. Call it generate sprite. And it needs to generate the sprite according to those values here. Let's see. We need to, first of all, check the coordinates within the texture. So let's go back here and check that. So first of all, let's first deal with the tiny cacti here. Let's see. So the width of one cactus appears to be 36, right? No, actually, I think it's 35. No, it's 36. No, that's the height. Sorry. The width is 17. Oh, sorry. So the height is 36. That is for sure. So let's create a constant here. Let's call it tiny cactus or small cactus sprite height 36, and I guess the width is 17, but I'm going to go ahead and check this again. The width of this each individual cactus here is 17 pixels, so that's fine. Let's see. We need to also check the start coordinates here. So the origin within the texture seems to be 228 and 0. So small cactus texture pos x 228 and texture pos y is 0. That is okay. Now let's see. I'm going to go here. No. Let's take care of this first. Okay, so if it is not large, whoops. So if large is false, we want to create small cactus group, and otherwise we want to create large cactus group. Oh, cactus, whatever. Let's go up here, create an instance of Sprite, and I think we designed it to be mutable, right? Yes, all of the properties can be changed except for the texture. That is fine. So actually, let's initialize this with null. Go down here and already add a return statement. And now here we need to actually instantiate and initialize this sprite. Okay, so if it is large, then we need to use these coordinates. Sorry, if it's small, if it's not large, then we need to use these origin coordinates. So, but we also need to check for the group size. So let's see. If I guess basically we just need to calculate an offset here for each. Yeah, right, got it. Let's say int offset x equals 0. Then if size equals small, offset will still be 0. Else if size equals medium, then the offset will be 1, and otherwise the offset will be 3. And I will just remove this here. We could also use a switch case syntax here, but it doesn't really matter. So if the group size is small, so basically by offset, what I mean here is that basically the number of sprites that we need to move the origin to the right. So offset 0 would be this one, offset 1 would be this one here, and offset 3 would be here. So yeah. And we also need to set the width. So let's say width is equal to this constant here. But then we need to adjust it, and I actually do need to add the braces. Like this. Oops. 3, right? Yeah. Yeah, I guess that's fine. And now we can do simply call the constructor of Sprite, pass the texture, which we have been passed here. No, we haven't. We actually need the texture. We need to add it to our constructor. Texture 2D. Texture. Well, let's call it Sprite sheet. And then here I will add a parameter to the generate sprite method, which will also be of type texture 2D. And call it sprite sheet as well. And then here I will simply pass the sprite sheet to the constructor. Then X will be the small cactus texture pos X constant plus offset X multiplied by the width, right? And the width will be simply the width variable that we declared up here. Oh, I missed the, I forgot to pass the Y position, which is also a constant. Then the width and the height is also a constant, like this. And I guess I can format this a little more nicely. Like this, I guess. Whoops. Or maybe like this. So yeah, so the start position of the sprite within the texture is this constant value plus the offset multiplied by the width of each individual small cactus sprite. That should be correct. The Y position will always be the same. The width also depends on the group size, and the height will always be the same. Yep, seems about right. Now let's do the same thing for the large sprites. But I guess let's test this before we do anything else. Why does it? Oh yeah, okay, no, that's fine. Here in the constructor, of course, we need to also actually call this generate sprite method. But first we need to add property of type sprite. It may as well be a field, it doesn't really matter. And here initialize it by assigning the return value of the generate sprite method, and for that I need to pass the sprite sheet like this. So let me check. So obviously there's no collision logic or anything like that yet, but for now we don't care about that. Let me go ahead and move this to a separate file first. So right click here, quick actions, move type to cactus group CS. Now it's here in a separate file. And that's okay. Let's go into the obstacle manager. And for now, what we will do is here in the spawn random obstacle, we will just always spawn cacti and never the pterodactyls, since they obviously haven't been implemented yet. So let's just say obstacle and now we need to randomly determine the size of the cactus group, small, medium, or large. So let's say random next int next minimum value will be 0, maximum value. Actually, let's go into the cactus group class real quick and go into the enum definition here, and let's assign values. I mean, by default, the first value will be 0, the second will be 1, and the third will be 2. But just to make sure, I'm going to explicitly set those values here. And what I'm going to do is now here in the obstacle manager, I will generate a random integer between 0 and 2 inclusively, and then just simply cast that integer to a group size instance. So let's say here cactus group size. Oh, I didn't mean to add a pair of parentheses here. Cactus group size small, and cactus group size large, and I have to cast these to integers. And I think here I need to actually add 1 here because it's not inclusive. So the maximum value is actually exclusive. So if I need to add 1 to the maximum here to actually include the value. So now this will give us a random integer between 0 and 2. Say cactus group size random group size as like this. So we use these the integer values of the enum constants to generate a random value between 0 and 2 inclusively, and then cast that returned integer to an instance of cactus group size. And now we can simply say obstacle equals new cactus group as the sprite sheet here, which I guess right, need a reference to the sprite sheet. We don't have one. So let's go to the obstacle manager constructor here and add a new parameter of type texture2, texture2d. Name it sprite sheet. Then we're going to add a new field here, also of type texture2d. Name it sprite sheet as well. Then assign it here in the constructor. There we go. Now we have a reference to the sprite sheet, and now we can use that to pass it to the constructor here, like that. Is large will, for now, for testing purposes, always be false. And the group size, we can just pass it in here, the random one that we just generated, as an instance of T-Rex, which we can get via our T-Rex field. And the position will be, oh, let's see. What will the position be? I guess it's, yeah, simply the window width. So let's see. Yeah. Oh, the Y position. Obviously, we need to also define a Y position. So let's pass in here. For X, we can just use the window width. So we can get that from the T-Rex runner game class. There's a constant named window width. We can use that. And for the Y value, I kind of have to see. Let's just pass 100 for now as the Y position, and then adjust this later. Let's return the obstacle. Whoops. Here. Oh, no, we don't need to, sorry, we don't need to return it. We need to spawn it using the entity manager. Add entity, obstacle. And later on, we will change this logic here to also, so that it also spawns large cactus groups and also the flying dinos, the pterodactyls. So yeah, but I want to test this now. But remember, we said that the obstacle manager must be enabled before it does anything. Here. So let's go into the T-Rex runner game class, go up here and add a new field of type obstacle manager. Like this, and then in the load content method, let's go down here maybe and say obstacle manager equals new obstacle manager, pass the entity manager, then pass the T-Rex, pass the scoreboard, and pass the sprite sheet. There. And then in our event handler method here, when the T-Rex has completed its jump animation, we will go ahead here and say obstacle manager is enabled equals true. And I think that's it. No, one more thing. We need to actually add the obstacle manager to the entity manager like this, so that it gets updated. So the update method is actually called each frame. But I think that's it. Let's just give this a try. Yeah, obviously now nothing happens, but as soon as I jump, I think we went a little overboard with those values, 100 and 500. Let's just wait a second. But I kind of figure that we may have forgotten something. Right. One thing we forgot is to actually draw a sprite. In the cactus group class here, our draw method does nothing. So we will never be able to actually see that cactus group. So let's go ahead here and say sprite. Oops. Draw. Pass the sprite badge and the position. So that's one thing. And yeah, let's test this. Again, maybe our distance values of 100 and 500 are not ideal, but let's just wait up. Oh, there it is. Perfect. But it seems like it disappears too early. And I know why that is. Because I'm stupid. If we go into the obstacle manager here, obviously we don't need to despawn it when the X position is less than 200. What I meant here is minus 200, negative 200. So sorry for that, my mistake. So let's start it up again. Now it should actually despawn as soon as it leaves the screen. Obviously we can't prove that, but I guess this mistake also had an advantage because now we were able to see that it actually despawns at some point, and now that point will be reached as soon as it leaves the screen. So yeah, we're good now. So but we still have to deal with the Y position of the cactus. The thing is that it depends on whether it is a large cactus or a small one. But I guess we can simply go ahead and say, let's go into the obstacle manager class. Oh, we're already there. Let's go here. You know what? Let's just finish the cactus group class first. Let's stop jumping from one point to another. Let's go here into this class and actually finish implementing this generate sprite method here. So I'm going to go ahead and actually copy this. Paste it here and then adjust it. We need the width of the large cacti. So let's go into the texture here and see. Yeah, this seems about right. So the width appears to be 25 and the height is 51. Let's define those values as constants. Oh, not the position, the height. What does it say, 51? Yes, and the width is 25. 25, there we go. And also the origin here, the X and Y position obviously are also different. It should be 332. Let's just copy this, rename it, change the value. There we go. Large, that's already correct. And now go back into the generate sprite method here and initialize the width variable with this other constant, large cactus texture width. Actually, I should rename this. Sprite. So it conforms to the naming of these other constant pairs here. Now, go back down here, copy this, and this copy pasting here kind of is an indication that we could optimize this. But actually here, this is not correct. The large group in this case, for the larger cacti here, the large group is not actually just, we cannot calculate the width of it like we did with the tiny ones. We need to actually check the width here. And it's 76. Let's see. It actually might be 75. Let's see. Yeah, it's actually 75, so we can actually calculate it because it's just 25 times 3. So this is still correct. Let's change this here. Like this. And like I said, we could optimize this method here. It's kind of redundant since these two implementations here, these two branches, are mostly identical. It's just some variables that change, though. But I guess we can leave it like this. One could argue that it improves readability. But I kind of hate to see this redundance. I guess the only difference is the origin position and the width and the height. So I guess, yeah, let's optimize this here. Let's copy this here. Put it outside of the if block. Remove this here. And actually, instead of using these constants, we will go ahead and say, this is an integer, right? Yeah. Let's create a local variable called sprite width. Initialize it with 0. Another one, sprite height, also initialized with 0. And the position like this, and then all we need to change are these values here. So if it's not large, aka small, then we will say sprite width equals small cactus sprite width, sprite height equals small cactus sprite height, pos x equals small cactus texture pos x, pos y equals small cactus texture pos y. And now we can copy this, paste it here, and change these values. Like this. And this removes the redundance. So now here, we, instead of using the constant value, we can say sprite width sprite width. Oh. Like this, and here we use pos x, sprite width, pos y, and sprite height. Yep, this should be much better. Yep, much less redundant. And it should still work. What else? Okay, so now we're actually able to generate sprites for both the tiny cactus groups and the large cactus groups. Yeah, so now we can actually modify our obstacle manager class to also be able to generate the large cacti. So let's say bool is large equals random. Let's just say next double greater than 0.5. So now we generate a random double between 0 and 1, and if it's larger than 0.5, then is large will be true. And we can pass that here to the constructor, and then here the y position will be dependent on this is large flag. So let's say float pos y equals is large. So if it is large, it needs to be spawned a little. We need to move it up a little. So let's say 90, and otherwise, or actually maybe 85, and otherwise it's going to be 95, maybe. Let's see. And then pass this value here. So since the large cacti occupy more space, we need to slightly move them up on the screen, and that's what we're doing here. And that should be fine. Let's test this. There we go. I guess there was a large group. Yeah, I mean, the values are still, I mean, obviously it takes quite a long time to get 500 points, so another large one. Yeah, we should definitely change those values. There's a small one. It seems to be working correct. I mean, for testing purposes, this is quite all right. But we definitely need to change those values.